welcome to another of Mrs. C's maths lessons. Who spotted the deliberate mistake on the maths that I left you yesterday? I bet a few of you did, because you got to question 6 and it said this. It said it had a triangle, a right angle triangle like this. Where was the algebra to solve in that question that I set you? I mean, as the fact it's wrong as well is quite bizarre, but 6 centimetres here, 7 centimetres there, area of 14 centimetres. Where is the x? What are you solving? This is what you should have had for your question 6 on the board. This 6 centimetres should have been a g. So g here, 7 centimetres here, and an area equaling 14 centimetres. So you had to find out what the g was worth, okay? So let's just go through it, seeing as it is quite a difficult one anyway. So, remembering your formula for finding an area of any triangle, half base times height, remember, yeah? Half base times height. So, half the length of the base times the height, half of that. Half of g times 7, okay? So I've written it out for you so that you've got the formula there and what it equals. Half of g times 7 equals 14. Half of it. So what does g equal? So, in order to find half of something, you've got to divide it by 2, haven't you? So let's go up here. G times 7 divided by 2 equals 14 centimetres squared. Okay? So, we're getting to where we need to be now, aren't we? Okay, so let's write that out a little bit better. So, 7g equals 14. What's the opposite of dividing? Multiplying times 2. So 7g equals 14 times 2. What's 14 times 2? 28. So 7 lots of g equal 28. So g equals, how many times does 7 go into 28? 4. 7 fours are 28. Okay? Quite tricky, but not impossible once it's broken down. Okay? So sorry that I got that the wrong way round. Right, let's get on with today's lesson. Right, okay, we are moving up on to Algebra 4, Lesson 20, which can go into your book or onto your piece of paper. Lesson 20, still looking at algebra, loads of stuff that we could do. I'm going to look at 2 more things to do with algebra, and then I might leave it, otherwise it might just get a bit too complicated for you to keep on following. Might be something we might have to do when we get back into school. Anyway, I'm going to try to teach you this. If you don't get it, don't worry, it is quite hard. Right, here we go. So 3x plus 2y equals 20. These are together equal in that. Just since the start of algebra, that's what we've been doing. We've been balancing these equations to make this equal sign make sense. So 3 lots of something plus 2 lots of something else equal 20. And it's asking you to find all the possible values. Tricky, tricky. The only way to really do it is by trial and error, which is a bit boring, but it is the only way. So let me break it down for you. Right, so let's see. Let's just go for it. So 3 times what? 3 times 1 equals 3. Okay, plus 2 times something equals 20. Okay, so if we take 3 away from 20 and do the opposite operation, what is this 2y going to have to be? So 3 away from 20 equals 17, doesn't it? Okay, so that means that 2y is going to have to equal 17. Is that going to work? Because that is not an even number. So 2 times something is never going to equal 17. So that's not a possibility. Okay, cross it. 3 times 2 equals what? 6. Okay? Plus 2y equals 20. Okay. So 6 plus 2y equals 20. I think that's going to be doable. Okay? So let's take that 6 away from the 20. So 6 take away 20 is 14. So 2y equals 14. That is possible, isn't it? 2 times 7. So if x equals 6 and y equals 7, you're going to get to the 20. Okay? So that works. X equals 6 and y, 2y equals 14, so y equals 7 and y equals 7. So that actually does work. 3 times 2 equals 6. So 2y is going to be 2 times 7, which is 14. 6 plus 14 equals 20. Okay, we've got that. So let's go to the next one. 3 times 3 equals 9. Okay, let's take the 9 away from the 20 to see what the 2y could be. 9 take away 20, 20 take away 9 equals 11. Another odd number. So that's not going to, there's going to be no multiples of 2 that are going to make 11. So again, that is not going to work. So 3 times 3 is not going to work. 3 times 4 equals 12. This is looking better, isn't it? Okay. So if we made x4, 20 take away 12 will leave us with 8. So what does that mean? So 2 times something to equal 8. 2 times 4. Okay. So y equals 4. So when x equals 4, 3 4s are 12, plus y equaling 4, 2 times 4 is 8, that will equal 20. It's hard work, isn't it? You've got to try to work out both sides of this to equal that. So you really are having to think laterally. So let's go to the next one. 3 times 5. That's going to give us an odd number again, isn't it? And 2 times something isn't going to make an odd number. So that's not going to work. 3 times 6. We're going to nearly go bust, really, aren't we? 3 6s are 18. Okay. 18 away from 20 equals 2. So 2y has to equal 2. 2 times what equals 2? So when x equals 6, y equals 2 times what equals 2? 2 times 1. Okay? Quite tricky, I think. I think I will still try to set you a couple of those to see, going by trial and error, working out what one side equals, and then seeing what the other side could equal to balance out this equation. Could you manage to work that through? It is just trial and error. There's no way around it other than keeping on trying different combinations of number to get back to this. Okay? Right, so I'm going to set you a few of those. If you feel that you could do that, have a go. I'm now going to go through a couple of algebra problems that come up on SATs papers to see if you understand them, and maybe set a couple of problems as well, which you might be able to do. Okay, back in a minute when I've got them set on the board. So here we go with a SATs algebra problem. This is from a genuine SATs paper, okay? Not very well drawn. Some of you may have attempted it because I set a little bit of extra work, and you may have had a look at this yesterday and you may have understood it. If you didn't, that's fine. Thought I might go through it just to try to make you see how algebra is used in exam papers, okay? And how it's used in problem solving. So we had two drawings, okay? This shape and this shape, 1, 2, 3, 4, 5, 6. So this is a hexagon, the B is a hexagon, and the A is a funny kind of cone shape, really. So I've given them an algebraic symbol, really, to help you understand what the difference is. And I've written out the equation. So 3 lots of A, would you agree if we're calling that A? And 2 lots of B, the value is 147. So the other thing that we know is that the value of 3 lots of A and 1 lot of B, there's only one hexagon, is 111. So you've been asked to find out what the value of the hexagon is and what the value of the cone shape is, the A and the B. Okay, well, let's write that in there. So that can be A and that can be B. Right. So the difference between this equation and this equation is what? We've got 2b here and just b there. 2b here and just b there, okay? So that is the equation for this, and this is the equation for that. The difference is one hexagon. So what the difference, there's the word, the difference is one hexagon. So how are we going to find the value of that one hexagon? Find the difference. This is this, 147, this is this. So if we find the difference, we will find out what B is worth. Let's do it. 147, take away 111. Okay, so 1 from 7 is 6, 1 from 4 is 3. Wow, as easy as that. So B is worth 36. Right. So if B is worth 36, and then this, B is worth 36, and the whole value is 111, what would happen if we took that 36 away from the 111? So we're going to put the B in here, that is 36. So let's write it as an equation. 3a plus 36 equals 111. We've done these before. 3a, 3 lots of a, plus 36, the total value is 111. So how are we going to work out what 3a is? Opposite operation. 3a is 111, take away that 36. Okay, so let's do that. 6 to 11 is 5. Borrow there. 10 take away 3 is 7. So 3a, 3 lots of that is 75. So if 3a is 75, what is a? 3 times a equals 75. So 3 divided into, 72, into 75 is going to give us what a is worth. Some of you will have worked it out already, I'm sure. 25. 25. Yes. You've just done a stats question, okay? I'm going to put a variety of different things on the board and I'm just going to see how you get on with them. If you don't know how to do them, it doesn't matter. Give them a try. Okay, back with you in a minute. Right, here we are with today's problems and equations to solve. So for these 4, you have to use trial and error to balance this side of the equation with that. 2 times something plus something else to equal 10. Okay, so you do your 2 times table, it's got to plus something else to equal 10. What can you do before you go bust? Same here. 4 times something plus something else to equal 22. What are the answers? There's more than one and you just have to go through your 4 times table. And here, even a little bit more complex, you have to go through your 5 times table and your 3 times table to see what together will add up to 37 in those times tables. So there's a bit of working out to do, but I do believe you can do it, okay? Just get the 2 sides of the equation equal to see what x and y possibilities are. This is one of the extra questions that I've set today, but I've set it out as a problem for everybody to do, okay? This is a SATs question, a SATs problem, okay? And this is the formula for cooking a chicken. This is real life. This is what you get on the back of your chicken from Tesco's, okay? So it's 20 minutes plus 40 minutes per kilogram. So the weight of the chicken, okay? So it's asking you how long will it take to cook a 3 kilogram chicken? What do you know? And what have you got to do to equal the cook time? What have you got to do to that weight? And the next one's slightly more complicated. So you've got to go back to what is the weight if it takes 100 minutes to cook. So write out the formula, put in what you know, and get back to the weight. Just write down what you know and what it equals and solve that equation. You can do it. Come on, you can do it. Give it a good try anyway. I'll be back with the answers tomorrow. Remember to like, turn on post notifications and subscribe.